Introducing the amazing Mr. Kong!
Hey! When? No, please. Stop the applause. Stop the applause. When? No, when? Stop the applause. When? Stop the applause. Oh, that when. Oh, okay. Ladies and gentlemen, I kind of wanted to do a screencast that bridges together what we've been working on with polynomials and synthetic division. Ladies and gentlemen, our main focus with polynomials is, again, solving polynomials, or what we like to call finding the zeros of the polynomial. But the first way that we learned how was by factoring, right? So to find the zero of a polynomial, I know I put 0 in for y, and I try to solve for x. By 1. And I say, all right, let's find the zeros by, oh, that looks like it might be groupable. Well, notice the ratio of 1 to 7 is not the same thing as the ratio of 14 to 8. Because that's not the same ratio, I cannot factor by grouping. Well, I can't factor by grouping, I don't know how to solve for him. So we're going to use the rational roots theorem, which is on another screencast you can watch. I know that if this polynomial has zeros that are rational, and again, rational means there's no square roots, right? I know that it would come from a list created by dividing my constant in the function, 8, by the leading coefficient, 1. Now, when I say that, I mean the factors of the constant and the factors of the leading coefficient. So I'm going to go through and I'm going to list out all the factors of 8, which are positive and negative 1. You always have to include the negatives. Positive negative 2, positive negative 4, and positive negative 8. In the denominator, all the factors of 1 are just positive and negative 1. Here's what the rational roots theorem says. My list of possible rational roots are each of these top numbers divided by each bottom number. So 1 divided by 1 is 1, positive and negative. 2 divided by 1 is 2, positive and negative. 4 divided by 1 is positive and negative 4. 8 divided by 1 is positive and negative 8. Here's what this says. It says hi. If this polynomial has a zero that's a rational number, it's going to be one of these numbers. Positive 1 or negative 1. Positive 2 or negative 2. Positive 4 or negative 4. Positive 8 or negative 8. It's got to be one of those. Right? Well, we know from what we talked about with synthetic division, if one of these numbers is a 0, if I did synthetic division on him, if I get a remainder of 0, I know that value is an x-intercept, and therefore a 0. So here's what I'm going to do. I'm just going to go through this list, and I'm going to perform synthetic division on each one of these, using each one of these possibles, and this function. Okay? Now, I can start with any one of the numbers. I can start with positive 1, I can start with negative 1, I can start with positive 2, you can start with negative 2, whichever you want. Sammy, which one do you want me to start with?
Negative 2. I'm
going to start with negative 2. So I'm going to put a negative 2 in the box. I'm going to put a 1, a 7, a 14, and an 8 outside the box. Bring down the 1, negative 2. I multiply negative 2 and 5 is negative 10, is 4, is negative 8. High five! You found a 0! Look at that. Look at that. Washing machine. Yay! Love the washing machine. Folks, since that remainder is 0, I know that negative 2 is an x-intercept, right? So I know that one of the zeros is negative 2. Well, moreover, didn't we say that synthetic division creates a smaller polynomial from these numbers? Don't I also know that x squared plus 5x plus 4 is the polynomial created when I divide the original polynomial by x plus 2? Well, if I set this guy equal to 0 and try and solve, wait a minute, I know any quadratic I am given I can solve. Couldn't you factor into x plus 4 and an x plus 1? Giving me x equals negative 4 and x equals negative 1. And lo and behold, I found all my zeros. The negative 2, by just trying the list of possibles, and solving the quadratic that I created, negative 4 and negative 1 are my other zeros. I've now found all the zeros of this polynomial. Now, I'm not going to lie to you. Sammy must have very good luck. I'm going to take her to the lottery store later. Out of these 8 choices, she picked one. I mean, the ones from this list that worked were the -2, the -1, and the -4. Those would have been the other ones that would work. If you would have tried +1, +2, +4, +8, you would have gotten a number that's not 0 as your remainder. Okay, but she's just a lucky child. Okay. But anyway, that's where synthetic division and polynomial zeros, what they have in common. Synthetic division can help me find zeros. Hopefully that's helpful. Talk to you later.